We talk about Chapter 15, the first three assessment statements of Chapter 15. First thing we're going to talk about the radioisotope carbon-14. So carbon-14 is going to be written this way. Carbon-14 is a naturally occurring isotope with a half-life of 5,730 years. Carbon-14 is produced in the environment by neutrons being bombarding the upper atmosphere, nitrogen-14 being converted into carbon-14 with one proton being released. The decay of carbon-14 is also spontaneous and natural. Of course, it takes 5,730 years for half of it to be decayed, but carbon-14 is going to decay into nitrogen and a beta particle being released. Carbon-14 production is in equilibrium with its decay, so the amount of carbon-14 carbon-12 ratio stays the same. The neat part about this is carbon-14 is incorporated into carbon dioxide, which is taken up by plants, and in the end all living things will have it because we'll eat the plants or some other animal will eat the plants and we'll eat the animal, and then we'll also get the carbon-14 in our body. And so as long as we continue to eat, the amount of carbon-14 carbon-12 ratio will stay the same as the atmosphere, as the same as in our bodies. That will stay the same. When an organism dies, it will no longer take in the carbon-14, and so over time the carbon-14 is going to decay, and as the carbon-14 decays, we're going to have a low amount of carbon-14, and the carbon-12 will stay the same. So we can measure this carbon-14 carbon-12 ratio, and we can estimate the age. After about 12 half-lives, though, the amount of carbon-14 gets so small it cannot be measured. So 12 half-lives times 5,730 years is roughly about 100,000 years is what we can use for carbon-14 dating. The limit is up to about 50 to 100,000 years. So anything older than that, we cannot use carbon-14 dating. We can also date older objects by using potassium-40. Potassium-40 has a half-life of about 1 million years. It decays to argon, and so what happens is we're going to look at the potassium-40 argon-40 ratio. Brand new rocks from volcanoes going to have a 100 to 0 ratio, and so as potassium rocks will erode and stuff, potassium-40 will be incorporated into the sedimentary rocks, and then as the rocks get older, this potassium-40 will decay into argon-40, and it can be used to date rocks over 1 million years old. How we can find the half-life of something is by looking on a graph. We can graph the amount of radioisotope that is still existing and the amount of time, and if we were to then look at it the half-life of this, so over we have half as much, so I'm at 50%. So over at half the amount, we can find out how long it took for it to get to a half, and we will call that its half-life. And so the half-life is the time it takes for half the amount of substance to decay. If we want to find how much substance is around, we can look at the percent of isotope that is left over and see how long it took us to get to that percent. Let's say we are at 10%. So we come to 10%, go across to 10%, and we'll see that it took 15 days for that to decompose down to the 15% mark.